This video is going to cover the notes on gravity. So you should have a handout that looks like this. It has some fill-in-the-blank notes with some images. It may already be in your journal on page 1. If not, grab the separate piece of paper like this. Okay. Now I know that gravity is something that you've talked about before in elementary school science. We're aware probably a little bit of what gravity is, but to be sure that we have an official definition, we are going to define gravity as the attractive force between objects. The attractive force between objects. So that means that it's what is attracting objects toward one another. Now, all matter has gravity. We'll talk about what affects the amount of gravity, but you see here this word is underlined. All matter has gravity. Okay. For this unit, since our focus is space, we're going to talk about how gravity affects the solar system. And so if you look to the left over here, we kind of see a diagram of the solar system. We have the sun, and then the following planets. You can see there's Mercury, Venus, Earth, okay, and there's our moon. The solar system is really held together by gravity. It's a huge factor in the way that objects are positioned in our solar system and the way that objects move in our solar system. So we're going to say the solar system, it says, appears to have formed from a disk of dust and gas drawn together by, you guessed it, gravity. Okay, again, gravity is the force that pretty much holds the solar system in place. It keeps the planets and moons and other celestial objects where they are and where they're supposed to be. Okay, we know that the planets move around the sun, that the sun is the center of the solar system, and that is because of gravity. So now I'm going to move over here. I said that all matter has gravity. It just depends on the object as far as how much gravity it has. So the strength of the force of gravity, so how strong gravity is, the strength of the force of gravity between two objects depends on mass and distance. Okay, mass and distance. So mass, I'm going to talk about that one first. We've talked about mass before, especially way back. This was in our very first unit. It was one of our units of measurement, right? Mass is the amount of matter in an object. Okay. How many atoms are there, right? How much mass? Typically we associate that with size. Not always, but for the most part. So here it compares an elephant to a bee. Okay, if we were going to compare the mass of an elephant to the mass of a bee, we would say that the elephant has a lot of mass compared to the bee. A bee has very little mass. The other thing we're going to talk about is distance, right? And we'll talk about some of the changes right here. At the top it says all objects attract toward each other. So right now if I have these two objects, and we're not calling them anything, they're spheres on our paper, right? But we're just going to use these as an example, okay? If these, to show the gravity between these two objects, we would draw arrows, okay, and it talks here about arrows. Remember, arrows represent forces. We talked about that when we talked about some of the Newton's laws and force and motion. So we would say that these objects are attracted toward each other. Okay, and we could measure that with this amount of force, this size of the arrow. If mass increases, notice that now the objects are bigger. If mass increases, the force of gravity increases. So now if we were to look at the force, we would have a much bigger arrow, okay, because now we have much bigger objects. So if as mass increases, the force of gravity increases. The sun is the biggest object in our solar system, and that's the reason why it has the strongest force of gravity and why all of the planets move around the sun, because the sun has the greatest mass. It is the biggest of all the objects in our solar system. If distance increases, so as the objects move farther apart, remember up here they were closer together, now they're farther apart. If distance increases, the force of gravity decreases. So now we would have a very small arrow to represent the force of gravity. As you study more about each of the planets, you'll kind of see how the size of the planet affects the amount of gravity that it has and how it responds to the sun's gravity, as well as the distance. The farther away from the sun, the less effect of the sun's gravity on that planet. So these notes, if you have not already, need to be glued into page 1 in your journal. Before we even get there, let's look at our table of contents. So the last thing we had in our journal was our tracking chart over here on page 14. So on the right, we have Unit 11 space. You can put today's date. Our title is Gravity, and this is going to go on page 1. Again, some of you I know may have already glued it, but if you haven't, page 1 is going to be the next right side page. You're going to have to turn your journal sideways, and this is going to go along this side. Now, if you would like to take a little bit of time to go through and color your notes, you're more than welcome to color in the gravity and the planets and other things like that. That's why we got these doodle notes for you.